Okay, so we're looking at multiplying rational function. So we have some rational function, and it turns out we essentially have the multiplication. This dot here stands for multiplication. Pardon me, of two of them. Now, we could go about this a couple different ways. I could decide that, this is a set of brackets here, and this is a set of brackets, and this one has a set, and this one has a set. And we could go through, this is essentially fraction multiplication. So it's the idea that if I had, let's say like 2 over 3 times 1 over 4, well, I can rewrite that as 2 times 1 over 3 times 4. The only thing is when I go to do that, we're going to have to do some, it's called binomial distribution. Or maybe they call it FOIL, where you have to do this times this. Yeah. And we're going to get this really big thing that we're just going to have to factor again. So a better route is to actually just factor everything when they're small little equations. And then we can just butt up the factor versions together without having to do any expansion. Okay. So with that being said, we're going to just kind of look at these one at a time. I'm going to try to go through it a little quicker than the last one. But I'm going to look at this as 4 different questions I have to factor. So I have 1, 2, 3, and 4. Okay. So I'll do the very first one in yellow. I'll do that over here. 5x minus 10. This is a linear question. I can common factor out 5. 5 comes outside the bracket, and it looks like I end up with x minus 2 because that's what each of those is. So in my f at x version, this now becomes 5x minus 2. Okay, so that's one set. I'll put it in yellow here. Oops, drew right through it. Sorry. The next one, we have same idea. This is a linear question. Turns out I can take 4 out. 4 comes out, I get x plus 6. Very nice. So now I can write this as 4 times x plus 6. I've got 2 of them already. And those ones were a little more straightforward. The bottom ones are quadratics. So they're going to be a little more work. Oh, that's a better way of making boxes. There we go. Okay, the first one here is x squared minus 36. This is a special case. I could break this apart, do decomposition, but this is actually called a difference of squares. So if you notice that, you actually know that the shortcut to this is to set up 2 brackets, find the square root of the first term. Square root of x squared is just x. Put it as the first term in each bracket. Square root of the second term, square root of 36 happens to be 6. And I just add and subtract. Okay, this happens to be a special case one. So noticing it's a special case is very handy because it speeds up what otherwise would have been a pretty long process. So now that I know that, on the bottom here I can rewrite this as x plus 6, x minus 6. Okay, and then finally I have a standard form. This one is a product sum, and it just so happens the a value is 1. When the a value is 1, I can jump right to the conclusion here. I know that my first term in each bracket is going to be x and x, and I just need to find those 2 numbers that multiply to this and add to that. 7 and 2 work quite well. If I have positive 7 and negative 2, positive 7 times negative 2 is negative 14, and when I add them together, I get positive 5. Okay, so I did that part quickly. Hopefully that was okay. And the reason I did it quickly is because I want to focus on the rational number stuff. So on the bottom, we get x plus 7, x minus 2. So even though these brackets look like there's a lot to it, each of these brackets represent some number. And there's a rule of multiplication. Always forget which one it is, whether it's commutative or associative. I think it's associative. It doesn't matter the order you multiply things in. You can multiply in any order. So what we're going to do here is I'm going to try to line things up. 5 times 4. I'm going to move x plus 6 over here. And then I'm going to move x minus 2. All of these are multiplied by each other. Doesn't matter the order. And that's that idea of multiplying fractions. We always do the numerator by the numerator and then the denominator by the denominator. So I just butt them all up together. I'm going to do the exact same thing on the bottom. But while I do it, I'm going to try to line up things that might be similar. So for instance, x plus 7 doesn't look like I got anything on the top for that. X minus 6, I don't have anything on the top. I do have an x plus 6. Okay, so I've done x plus 7, x minus 6, x plus 6, and it looks like I have an x minus 2. The reason I've lined them all up because it's going to really help when we go to simplify. I'm just going to drop off a bunch. But before I do that, I do got to figure out what all of what my x's cannot be. So I got to set up 4 different ones here. We're essentially saying that x plus 7 cannot be 0. X minus 6 cannot be 0. X plus 6 cannot be 0. And x minus 2 cannot be 0. Well, if we do that, what that means is x cannot be negative 7, x cannot be 6, x cannot be negative 6, and x cannot be positive 2. So I got a whole bunch of them. Yeah. So if we were to write a domain, I'm not entirely sure. Do you guys use this? Like x as an element of the real numbers, such that we would say x cannot equal, and then we would just list them. Can equal. Usually we go from left to right. We'd say negative 7, negative 6, 2, and I'm running out of space here. 2 and 6. These are all the numbers it cannot equal. Okay, which means we have a whole bunch of vertical asymptotes if we go to graph this. Now, luckily, I don't think they're going to ask us to graph this one. They do want us to simplify, though. So I take a look. X minus 2, got both of those. X plus 6, I got both of those. I got to quickly do a little bit of multiplication. Hopefully that's okay. 5 by 4 is 20. And then on the bottom, we end up with our x plus 7, x minus 6. Now, they may say we want it back in standard form, in which case you got to like do your FOIL again. But for all intents and purposes, this is the simplified version. This is essentially what you're looking for. So when we zoom out, that's all the work we did. We originally had it. We factored both numerators and both denominators. So we went through the factoring process. We wrote down them all in factored form. We made sure we figured out all the versions of x that it cannot be. And then we reduced. We simplified everything to get this final answer on this piece.